Okay, so we started the chapter 8 portion on how to find your perfect sample size with a certain amount of error. So this part is going to be about confidence intervals. You know, when we do get a sample, it's basically not going to be perfect because it's not the entire population. So basically what we're doing with confidence intervals is saying there's a little bit of error here, so let's add and subtract some margin of error to what we got from the sample and see what we would expect our population, you know, the interval where we would expect our population to be. So my estimates about the population are not exact. The estimates that you get from the sample are not exact. So I need to add and subtract a margin of error to get an interval of where I think the population parameter will fall. So an example end result of confidence intervals is we can be 95% confident that the population proportion of contaminated water on flights is between 7% and 17%. Notice I'm giving an interval and making an estimate about the population. Again, my sample's not going to be perfect, so I'm adding and subtracting a margin of error to that. So our point estimate is just that sample proportion. That was 12. So you can see the margin of error was 5%. I added that to get the 17 and subtracted that from the 12 to get the 7. So we took the information from our sample, added and subtracted the margin of error, so sample proportion was 12%. Margin of error was found to be 5%, and we'll talk about how you find the margin of error later. So the confidence interval is between 7% and 17%. The way I would word that, we can be 95% confident that the population proportion of contaminated water on flights is between 7% and 17%. Whenever I'm doing confidence intervals, I'm making inferences about the population. Okay, so let's talk about this margin of error thing that we need to add and subtract to the sample estimate. So what goes into the margin of error is the confidence level, how confident I want to be in terms of this inference about the population. This is something I choose. The common confidence levels are 90%, 95%, and 99%. And basically what that means is if I want 99% confidence, then there's 1% chance of making a type 1 error, which we'll talk about later. So basically think of it as 1% chance of error is 99% confidence. 95% confidence is 5% chance of error. Okay, but again, we'll talk about type 1 and type 2 errors in chapter 9. I'd love to have a great deal of confidence, but you'll see how things change, and you might need a bigger sample size if you have more confidence and that kind of thing. We'll also look at variability. If my data has a lot of variability, that's going to increase the amount of error. So yeah, I mean, it kind of means my data is all over the place, so there's more error there to take into account. And sample size. If I have a huge sample size, that's great. I'm going to have less error. But if I have a tiny sample size, there's more error because I just didn't get a good enough sample. Okay, so what happens to the confidence interval as these things go up or down? For the confidence level, if I want to be more confident, I need a wider interval because it has to include more possibilities. Again, confidence level is something I choose, but the common ones are going to be 90, 95, and 99. It might raise a red flag if you choose a confidence level of 80%, which you'll see you might be motivated to do because that narrows the interval. And then variability. A lot of variability in my data means more error and therefore a wider confidence interval. And again, sample size. Smaller sample size means more error and therefore a wider confidence interval. So I want as big a sample size as I can get. And like we saw in the beginning of chapter 8, we can figure out how big a sample size we need based on the amount of error we're willing to take. Okay, so there'll always be some error if I'm taking a sample instead of getting the whole population. Confidence helps me decide how much margin of error I'm willing to have. So 99% confidence would be great, but that might mean a large window of actual possibilities and a very large sample size, and we might not have the resources for that. So if it's possible, maybe I want to reduce it to 95% or 90% to help me out. And my boss might not be too happy with the results if I go any lower than 90% confidence. Okay, so let's look at some examples. Let's say I'm interested in the proportion of television viewers tuned into a network. Millions of TV viewers constitute the population, so I take a random sample to estimate the population proportion. Pi is the symbol for population proportion. Or let's say I'm interested in the mean turnover rate per year of employees at a software company. 12 months to wait in the year, a monthly sample estimates the yearly turnover rate. Okay, so I'm estimating mu, which is the population mean. Let's say I'm interested in average annual consumption of alcoholic beverages by women of age in Europe. A random sample of 20 women yields an estimate for the population mean. Okay, I'm going to stop there.